Hello again. We're still working on energy or enthalpy of reaction, and here we have you put salt in water and you get hydrochloric acid and sodium oxide, and they say the enthalpy change for this reaction as written is 507.3 kilojoules. This is implicitly positive, which means our reaction is endo or exothermic. Positive means endo, so we're putting energy into this reaction. And the first thing they ask for is a thermochemical equation for it, and there are two ways you can write this. Because the heat is something we put in, it's like an ingredient, we can write our reaction with heat on the left side. 507.3 kJ. This is one way to write a thermochemical, the heat on the left meaning it's something we have to put in to make the reaction go. Or, if you don't want it in amongst the chemical species, you can write the reaction separately and then afterwards put a delta H equals positive 507.3 kilojoules. Those are equivalent. You can use whichever one you like, but make sure you can read both versions because you will see them both. Draw an energy diagram to represent the above. Okay. This reaction is endothermic, meaning you have to put heat into it, meaning the reactants start at lower energy and then they go up by 507 as you put that energy in. So your diagram should start low and go high. We don't know anything about activation energy, so I'm not doing a bump in the middle, I'm just doing this part. And then you list your two reactants, 2NaCl plus, apologies. All this should be on the line, but I'm writing a little ugly today, so in the interest of keeping it halfway legible, I will sometimes have to move stuff around. So you put your reactants, you put your products, and then you label the enthalpy change. And in this case, I'm going to put 507.3 kilojoules. It's obviously a plus because the graph is going up. Even if this were going down, I don't think I would put a negative sign in here. It would be obvious from the way that the curve starts high and goes low that we have an exo reaction. So the shape of the diagram can do the same job as that sign normally would. Calculate the molar enthalpy of reaction for hydrogen chloride. So this reaction says you will spend 507.3 kilojoules for every 2 moles of HCl, which is one way you could give the answer. You could say our enthalpy change is 507.3 kilojoules per, because of the 2 right here, we say 2 moles HCl. And you could stop there, and I often do, in fact. Or, if you want, you can do the math here. 507.3 divided by 2 is 253.65. And if you divide that out, the unit will still be kilojoules per mole of HCl. Either of those does the same job. What mass of sodium oxide is produced if the reaction consumed 126 kilojoules? Okay. Sodium oxide. According to this reaction, for every 507.3 kilojoules you spend, you will get 1 mole of sodium oxide. So from the reaction, we have 507.3 kilojoules will get you 1 mole of Na2O. And we're saying, well, I'm not using 507.3, I'm using 126. much Na2O will I get? If you cross multiply that, 1 times 126 divided by 507.3, you get 0.2484 moles of Na2O. If you're not into cross multiplying, your other option is to use N delta H. In this case, we would say the energy I'm investing is 126 kilojoules. N, don't know, not sure how much sodium oxide I'm going to get. Delta H would be 507.3 kilojoules per, in this reaction it's 507.3 per 1 mole of Na2O. And yes, mathematically it's a waste of time to put a division by 1, but if you make yourself do this, then hopefully it'll help you remember when this number is a 2 or a 3, because if you forget a 2 or a 3, very bad. If you divide this, you will find the exact same N, so we're getting 0.2484 moles of sodium oxide, but they didn't ask for moles, they asked for the mass of sodium oxide, so one more step. Mass equals number of moles times molar mass. We have 0.2484 moles of sodium oxide. Molar mass would be 2299 for sodium times 2 plus 16 for a single oxygen, 6198. And if you multiply that out, you get 15.3958. 3958 grams. 4 sig digs. Molar mass had 4 sig digs. Yeah, everything's got 4 sig digs. So 15.40, I believe, grams. It should be our finished amount. I see in the key I got 15.39, so maybe I didn't carry enough digits when I went through this. If you run this with all the digits your calculator is capable of holding, I presume you'll get 15.39. I must have rounded something a little bit too hard here.